Algebra 2. We're here today to discuss Chapter 3.3, which is Graphing and Solving Systems of Linear Inequalities. So today this is going to be a system of inequalities instead of a system of equations. So your definition of a system of linear inequalities is just two or more inequalities in two variables. So we're talking about inequalities that you're going to put on a coordinate plane. A solution here is going to be any ordered pair that works in all the inequalities. And on the graph, that solution is going to be found in the overlapping area. So you're going to graph these linear inequalities, you're going to shade them all, and you're going to have some overlapping area. So the solution is that overlapping area. So the graph is the overlapping region, and then to graph them, we're just going to completely graph each inequality one at a time, and then what we get as the overlapping area is our solution. Alright, so here we go. Let's graph this system. So you probably want to put them in slope-intercept form to graph them, or that's how I'm going to do it. So if I start with the first one, and I'm going to go ahead and change it to an equation to graph it. And I'll add the 2y and subtract the 3. And I'm going to switch it all around so I get 2y equals x minus 3, because those canceled. So I get y equals 1/2 x minus 3/2. To graph it, we're going to start at negative 3/2, which is negative 1.5. And from that point, I'm going to go up 1 over 2. Don't go up 1/2 over 1. Go up 1 over 2. This would probably be a good time to get your straight edge out. Okay, so once I have my points plotted, I'm going to go back and say, okay, well, it's going to be a solid line. Draw that in brown so you can see it. There's my solid line. And then I need to shade it. So I'm going to pick a test point. My test point's going to be 0, 0. So if I test 0, 0 in this inequality, I'm going to get 0 minus 0 is less than or equal to 3. Is 0 less than or equal to 3? Yes. So then I'm going to shade the side with 0, 0. So I'm going to shade all of that side there. Then I'm going to look at my other equation, which is actually already in slope-intercept form. So I'm going to start at negative 4. Oops, I'm going to change my pen back to small here. Okay. And then I'm going to count a positive 3 slope, so up 3 over 1. And you might note where they cross, and I don't think that does cross exactly there, yep. And here I've shaded out my, there we go. This time it's going to be a dashed line. So we're going to draw in our dashed line. Still pick a test point, so I can still pick 0, 0. So 0 would be greater than 0 minus 4. Is 0 greater than negative 4? That is true. So then you're going to shade everything over here. And then what you're going to do is you're going to see where they overlap. And sorry, I don't have a great way of doing that on the program I'm using here. But you're going to see where they overlap, and you're going to come in and you're going to shade where they overlap darker. So this region here is where both of them were. So then you're going to shade that darker. So everything in that bluish area is a solution because all of those points work in both inequalities. So let's see that one more time. This time we have 3, and this is kind of a typical, what they have here at the beginning are actually 2 constraints. So if you might be talking about, time has to be greater than 0, or you might be talking about distance, and distance might have to be greater than 0. And so you see these kinds of things a lot. So we're just going to graph them. So x equals 0, and it's going to be solid. X equals 0 is this line right here. And it does say x has to be less than 0. Okay, so that's going to be someplace over here. I'm going to just kind of lightly shade that. Then it says y equals 0, and that's going to be another solid line. So here's the line y equals 0, and we want to be greater than that, so we're going to be someplace up here. So already you can see we're going to be in the second quadrant because that's where they both overlap. And then we're going to come in and graph the last one. And add y and add 2. Y equals x plus 2. So we're going to start at 2 and have a slope of 1. So we get something like that. Solid line. So there is my solid line. And if I pick a test point 0, 0, I'm going to get 0 is greater than or equal to -2, which is true. So I'm going to shade below that line. I know that looks like a mess there. But what you're getting, you know, really the entire graph someplace is shaded, but you want where all three overlap. And all three overlap in this triangle right here. So this triangle is your overlapping shaded region, and you need to shade it darker. All right, we'll do some more in class. Let me know if you have questions. Have a great day.